In this video, I'm going to go over question 4 from the November 2016 paper 2 for IB Math SL. So this is a calculator question. I can see in part B we're asked to find the area of an enclosed region. That's great on a calculator test because you can type in definite integrals right to the calculator, just to preview that that's coming. All right, so here we have the graphs of f and g, two functions that are given and both known, though g is written in a sort of funny way. If you're looking at this f of x in the function and thinking that's strange, you can imagine that this function is just negative 3 e to the negative x plus 1, because that's what f of x is. So there's a number of reasons why they might show it that way, but when we go to the calculator to type in the function, that's how we'll want to type it in. So they intersect at x equals p and x equals q, where p is less than q. Find the value of p and q. If you're looking for where two functions intersect, you can set them equal to each other. That's usually worth a point if you're showing it on the paper, even if that's all you know to do. But also, hopefully, it'll occur to you that since it's a calculator question, you can figure out where these two functions intersect graphically. So let's go to a calculator, add a graph, and see what the intersection points are. Add a graph. The first function is x times e to the negative x, so we want to make sure that we're using the multiplication sign when we type this in. Sometimes the calculator gets finicky if we don't show multiplication there, thinking that e is some kind of variable. So there's the function x times e to the negative x. And then our next function, if I hit tab, I believe I can enter another function on the same slide, or on the same graph, is negative 3 multiplied by, parentheses, x times e to the negative x, using the negative sign, not the subtraction sign, and then plus 1. Okay, so I can see that they actually do intersect at two places. It's pretty small, this window, so I think I might try to just adjust the window so I can see a little bit more clearly. I don't need to see very far, up, down, or left and right. All right, so if I'm trying to find these two intersection points, the calculator can get them for me. If I go to Menu, Analyze Graph Intersection, I just have to do them one at a time. So this one first, that's 0.357. Oops, did not mean to hit Control. Menu, Analyze Graph Intersection, and click left and right. And there's the other one. If you can't see it, you can always hover your hand over the label, click, and then drag it up. So 0.357 and 2.15 if we're doing 3 sig figs. And we have to pay attention to which one's p and which one's q. It says that p is the smaller one. P is less than q. So p is the 0.357 and q is the 2.15. Let's write that down here. So we have two solutions for x. You could write it like this. You could write it like this, and then we want to give that p equals 0.357. And you'll notice that I didn't pay any attention to what it said for y. It doesn't matter what y is when you're looking for solutions for x. It specifically says x is p and x is q. We don't have to write what the y value is at either one of those coordinates. You do have to sketch a graph of what you found using the calculator. So the first function looks something like this, the other function looks something like this, and we found these two coordinates right here and right here. And you do want to indicate that that's what you found. Maybe we'll call this x1 and x2. So somehow sketch a graph to indicate you used the calculator and a graph in order to find those solutions. Then, find the area of the region enclosed by the graphs of f and g. All right, so area enclosed by two functions crossing like this is always an integral of the top function minus the bottom function. And you've got to show that on the page for the working credit. So we want to say something to the effect of the integral from the left to the right, or from the smaller to the bigger. So those are our boundaries on our integral. And it's the f of x function that's on top there, the g of x function that's on bottom. If it's not clear to you which one's on top, which one's on bottom, you can put absolute value around these, and that way, even if you've subtracted in the wrong order, you can get full credit, you can still get the right answer, because the area should always come out positive. You could actually fill in the functions there for f of x and g of x, and you'll have to on the calculator anyway, but this we can evaluate directly on a calculator. So let's just remember how. When we go to calculator page, so we'll add a new document, new page to this document. On the menu, calculus menu, numerical integral lets you type directly in the functions all in terms of x and everything. You don't have to do any integration on your own. It's 2.15. And in here, it's a good idea to use the absolute value brackets if you're on a calculator. You can find those in the button next to the 9. And inside of the absolute value brackets, you'll type in the functions that we had, which were x times e to the negative x. This just takes some time. And minus, all right, I'm going to put another set of parentheses in here, negative 3 x times e to the x plus 1. Being really careful with multiplication signs, with parentheses, and you have to fill in x here so that it knows we're integrating with respect to x. We hit enter, and it calculates it for us, and it's 0.538 if we're rounding to 3 significant figures. So we just have to conclude with equals. And that's it for this one.